So, good morning to all. So, I think all of you are live. So, try to inform all others, your friends, to come live. So we can start the revision class of basic thermal engineering. So, today, and laws of thermodynamics. So, I just briefly explain you today about the system, what is the definition of system, boundary, surrounding, working fluid, and state of a system, thermodynamic systems, that is types of system, open system, closed system, and isolated system. With some examples, properties of system, intensive and extensive properties, with examples, definitions for properties like enthalpy, entropy, internal energy, specific heat at constant pressure, specific heat at constant volume, and also in the next class we will go for the derivation of Cp minus Cv equals to R. And also we go through the derivations of characteristic gas equation, universal gas equation, and also we discuss the quasi-static process. So in the same, we'll discuss about the zeroth law, first law, and second law of thermodynamics. So at the end, we solve some important questions, so which are important for your examination, the end examination. So this is what for the first chapter. Okay, now I'll start with the definition of system. What is a system? As you know, already discussed about the system in our classes. A thermodynamic system is a definite space in a space where some thermodynamic processes are taking place. You know that one. So in the system, we have types of system. We have open system, closed system, and isolated system. So this is important question for your theory examination. So the question will be, the nature of the question is define system and explain the types of system. So as you already defined the system, a definite area in a space where some thermodynamic processes are taking place. You write like this, the definition. And the types of system, open system, closed system, and isolated system. So we define the open system as the system in which both mass and energy transfers is called open system. And example for the open system is IC engine, compressor, steam turbine. And also the definition for a closed system is the system in which only energy transfers but no mass transfers is called a closed system. An example for the closed system is a piston cylinder, a gas filled in a piston and cylinder arrangement, an iron box, a tube light, where the only energy interacts, no mass transfers, is example for closed system. And the isolated system, the system in which no mass and no energy transfers is called isolated system. A very good example for the isolated system is the universe, and also you can have the thermoplasm as an example for the isolated system. And then the next important question is the properties of a system. So we define the properties as the characteristics of the system, so which indicates the condition of the system. So in the properties we have three types of properties. Generally, intensive properties, extensive properties, and specific properties. For diploma students, only the intensive and extensive properties are given for your syllabus. The intensive properties are defined as the properties which are independent of mass of the system are called intensive properties. Example for the intensive properties are the temperature, pressure, specific volume, density. And the extensive properties are defined as the properties which are depends on the mass of the system are known as the extensive properties. So all types of energy comes under extensive properties. Okay, energy is an extensive property. Entropy is an example for the extensive properties. Mass is example for the extensive properties. Volume is example for the extensive properties. Okay, the specific properties are not given for the diploma students. So you can also define the specific properties. So after the properties, so we define one more important question, that is definitions of properties like enthalpy, entropy, internal energy, Cp and Cv. So we define the enthalpy as a sum of internal energy and the product of pressure and volume. The enthalpy is denoted by the symbol H. Therefore, mathematically, the enthalpy is given by H equals to U plus PV. There, where U is internal energy in a kilojoule, pressure P is a pressure in Newton per meter square, V is volume in meter cube. Okay, and then we define the entropy as a randomness of the system which increases with the addition of heat and decreases with the removal of heat. Mathematically, the entropy is denoted by the symbol ds, ds equal to delta Q divided by T, capital T. That capital T indicates the absolute temperature. So you can define the entropy as the ratio of the heat transfer to the absolute temperature. The unit of entropy in entropy is denoted by the symbol capital S, and the unit of entropy is kilojoule per Kelvin. Then we define one more important property, internal energy. Internal energy is defined as the energy contained within the body of the system is known as the internal energy. So internal energy is denoted by the symbol capital U. So its unit is kilojoule. And then we define the specific properties or the specific heat. The specific heat generally is defined as the amount of heat required to rise unit mass of a substance through 1 degree Celsius. This is general specific heat. There are two types of specific heat. So one is specific heat at constant pressure, another one is specific heat at constant volume. So if you take a solid and a liquids, they have only one type of specific properties, specific heat. But if you come to the gases, it is having two types of specific properties. So that is Cp and Cv. For your syllabus, for diploma Karnataka students, so for your syllabus it is given the Cp and Cv, the definition of Cp and Cv. That is specific heat at constant pressure and a specific heat at constant volume. The specific heat at constant pressure is defined as the amount of heat required to rise unit mass of a substance through 1 degree Celsius at constant pressure. Its unit is kilojoule per kg Kelvin. And the Cv, the specific heat at constant volume, is defined as the amount of heat required to rise unit mass of a substance through 1 degree Celsius at constant volume is known as specific heat at constant volume. And these two definitions are very important for your end examinations. So you get a 5-mark question, define specific heat at constant pressure and define specific heat at constant volume. This is one more important question. And then we have a relationship between Cp and Cv. That relation between we have a derivation for 5 marks. Derive the relationship between Cp and Cv, or you can have the derivation. Derive Cp minus Cv equals to R. You have one more. The same question will be asked in a different ways. So after that derivation I will take in the next class. So today I am only engaging the some of the theory part of the first chapter. Okay, the derivation tomorrow, which are important derivation, I will discuss in the next class. So after Cp and Cv, so we have relationship between Cp and Cv, and then we have a characteristic gas constant. So after the Cp minus Cv equals to R, we have a characteristic gas equation, that is Pv equals to mRT. That is a one more derivation, so which we can derive in the next class. So after that we have a universal gas constant, which is denoted by R subscript U. The universal gas constant is defined as the product of molecular mass and the gas constant. So you know that molecular mass and the gas constant. The gas constant is a characteristic gas constant which is different for different gases. The R value is not fixed for all the gases. If the gases changes, if the element changes, the R value changes for the different one. And the Ru value, that is universal gas constant value, will remain same irrespective of the gases. And its value is 8.314 kilojoule per kg mole Kelvin. That value is fixed for all the gases. And the Ru is denoted mathematically Mr. Therefore, we can define the Ru, the universal gas constant, as the product of molecular mass and the gas constant. And then after the universal gas constant, we can define the quasi-static process. So the quasi-static process is asked for 5 marks. So as I already discussed in the theory class, since it is a revision class, so I just defined the quasi-static process. The process which is carried out very slowly, so that initial and end states are also in equilibrium, and also the intermediate states through the during the process the system follows are also in equilibrium states. It means the process the deviation of this process from the non-equilibrium condition is very negligible. So therefore, initial and end states are also in equilibrium, and also the intermediate states are also in equilibrium. That is what a quasi-static process. All the reversible processes are generally quasi-static in nature. It means the quasi-static process is a reversible process. But all the practical processes are irreversible processes. And then today in the same class, we will define some of the definitions like zeroth law, first law, and second law. Before that, I will define one more definition, that is substance which carries the energy from one position to another position, from one location to another location, which carries the energy. So if you take a steam engine or a steam turbines, there the working fluid is a steam. If you take the IC engines, so petrol or a diesel irrespective in engines, that is a working fluid. If you take the hydraulic turbines, the water is a working fluid. Okay, and then after the working fluid, we will go for the zeroth law of thermodynamics. So zeroth law of thermodynamics, so you get a 5-mark question, like define zeroth law of thermodynamics and first law of thermodynamics, or it will be combined with the first law of thermodynamics and second law of thermodynamics. So we can define the zeroth law of thermodynamics as if the two systems are in a thermal equilibrium with each other, with a third system separately. So that is what, if two systems are under thermal equilibrium with each other and also thermal equilibrium with a third system sub, that is what the zeroth law of thermodynamics. So you get a very important question for a competitive exams. The zeroth law of thermodynamics, you get a question on this. The basic temperature measurement, the temperature measurement, which law follows? During the temperature measurement, which law follows? You get the options like zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. That is entropy generation. So in that you have to tick for the zeroth law of thermodynamics, which is a basic for the measurement of temperature. And then we'll define the next first law of thermodynamics. There are so many statements for the first law of thermodynamics. The first law of thermodynamics generally is a law of conservation of energy. So that is what, energy neither be created nor be destroyed, but it can be transferred from one form to another form. That is what the first law of thermodynamics. So for in our class, we defined the first law of thermodynamics as the cyclic integral of heat transfer is equals to cyclic integral of work transfer. And also we defined the first law of thermodynamics as the summation of heat transfer in a cycle. In a cycle, the summation of heat transfer is equals to the summation of work transfer. That is what the first law of thermodynamics. And then the second law of thermodynamics. So there are two statements for the second law of thermodynamics. So that is what the Kelvin-Planck statement and a Clausius statement. The Kelvin-Planck statement will give the idea about the engines, and the Clausius statement will give the idea about the refrigerator and heat pump. So if you go for the Kelvin-Planck statement, it is impossible to construct an engine working in a cycle to transfer the heat from higher body temperature to lower body temperature without the two temperature reservoirs. So it means in order to get the work from an engine, we need two temperature reservoirs, that is source and sink. So that is what we define once again the second law of the Kelvin-Planck statement, as it is impossible to construct an engine to produce work with a single temperature reservoir. It means there are two temperature reservoirs are needed. And then similarly we define the Clausius statement, which is for the refrigerator and the heat pump. If you go through the formula for the first law of thermodynamics, that is, sorry, second law of thermodynamics, the Kelvin-Planck statement, the efficiency of that engine is denoted by 1 minus Q2 divided by Q1. So where Q2 is the amount of heat rejected to the sink and the Q1 is the amount of heat supplied from the source to the engine. Similarly, if you take for the reversible engines, we get some problems on the reversible engines. So efficiency is equals to 1 minus T2 divided by T1, where T2 is the temperature in a Kelvin of a sink, T1 is the temperature of source in a Kelvin. And similarly, if you go for the next, the Clausius statement. So the Clausius statement will deal for the refrigerator and heat pump. So there, it is stated as, so it is impossible to construct a device working in a cycle to transfer the heat from low body temperature to high body temperature without an external aid. That is, external aid is the work supply. Without any external work, you cannot transfer the heat from therefore, so definitely we need an external source, that is in the form of work done for a refrigerator, that is electrical supply is needed for the refrigerator and also for the heat pump. If you take the refrigerator, so like the efficiency of the engine is denoted by eta, that is here also the efficiency of the refrigerator and heat pump is denoted by the coefficient of performance, so which is generally known as COP of the refrigerator and heat pump. The COP of the refrigerator is mathematically given by Q2 divided by Q1 minus Q2, where Q2 is the desired effect. So you have to concentrate on the desired effect. So which is the desired effect in these two things, that is a refrigerator and heat pump. In a refrigerator, the desired thing is to cool it, to remove the heat, that is your Q2. And in case of heat pump, the desired effect is to heating, that is supply the heat to the source, that is Q1. So with this manner, mathematically we give the COP of refrigerator as Q2 divided by Q1 minus Q2. For a reversible refrigerators, T2 divided by T1 minus T2. And for the heat pump, it is Q1 divided by Q1 minus Q2. For reversible heat pump, this will be T1 divided by T1 minus T2. Okay, then we will go for these two are very important. So concentrate on more these laws, zeroth law, first law, and second law of thermodynamics, which are very important for your final examination, semester end examination. And similarly, we go for the next. So that is what the steady flow energy equation. One more important question. Steady flow energy equation, SFEE. So we have a derivation for the steady flow energy equation. For your syllabus, for diploma student, there is no derivation. So you have only direct equation. So that equation I will deal with the next class. And before that I define. You get the question like define steady flow energy equation. Define steady flow and mention the steady flow energy equation and mention each terms in the steady flow energy equation. So the steady flow, in a flow, the characteristics of the flow, such as pressure, velocity, so which will not vary with the time, and such characteristics and such flow is known as a steady flow. In a flow, the flow characteristics are not varying with the time, then those are called the steady flow, and we have the steady flow energy equation we will discuss in the next class. Okay, with this I conclude my today class. In the same way, so once again for all 4 semester diploma mechanical engineering students, so we are from the BLDEA'S Sri Sangan Basava Mahaswamiji Polytechnic College. Again, we will inform to all the students for the next class of basic thermal engineering will be taken in the tomorrow. So we also inform the time of the class. So with this class, I will conclude. Similarly, we will continue with the next class of hydraulics. So BS Nikam sir will engage the class, and the class of the timing of the class will inform shortly through the post semester mechanical engineering WhatsApp group. Thank you.